We're going to look at y equal to minus 1 over x, the green dotted line here and there, which is the reflected 1 over x reflected about the y-axis or about the x-axis. That doesn't matter. If I look at that, then what I must remember is that we have a domain of all real numbers except 0. The range is all real numbers except 0. The vertical asymptote and the horizontal asymptotes are exactly the same as for y equal to 1 over x, as well as the green broken lines, the y equal to x and y equal to minus x, which are the axis of symmetry. So, if I now want to do the red graph, let us do the algebra first. First of all, our denominator can never be 0, so we may not have x minus 1 equal to 0. That implies that x may not be 1. So, in the domain, we can have anything except 1. Again, the numerator cannot be 0. So, therefore, we cannot have an answer of 0. So, the vertical asymptote will be x equal to 1. Horizontal asymptote will be y equal to 0. The lines of symmetry here, we simply take the denominator, we put that there, and then we take the negative of that. In this case, because we do not have a q value. So, this is then minus x plus 1. So in this case, the red graph is a green graph shifted 1 unit to the right, because our p-value is equal to plus 1, which is positive. That's why we move to the right. If we now look again at our green graph, remember the green graph is now y equal to minus 1 over x. This is the line y equal to x. This is the line y equal to negative x. And then our vertices will lie on the line y equal to minus x. And the same with the red graph. We've seen that this is now y equal to x minus 1, and you can see that it cuts the y-axis. The c value is minus 1. We've done the straight lines before. So this is a line y equal to x minus 1. Axis of symmetry shifted 1 unit to the right here. And in this case, our other one, y equal to minus x, also shifted 1 unit to the right, and that is the graph 1 minus x plus 1. So it shifted 1 unit. You can see it goes through the x-axis at 1. And also my b value shifted to my d value, which is 1 unit to the right, and my a value shifted 1 unit to the right to get my c value there. To solve for my vertices, y equal to minus x plus 1 and y equal to minus 1 over x minus 1, I must solve that simultaneously. So I will have minus x plus 1 equal to minus 1 over x minus 1. We can do it like this. So remember, x minus 1 is unequal to 0, so I can multiply by that. So I get minus x plus 1 times x minus 1 is equal to minus 1. So I'll get minus x squared plus x minus 1 equal to minus 1. So that gives me minus x squared plus 2x equal to 0. So I can write minus x minus 2 equal to 0, so x is 0 or x is equal to 2. We can check it here on our graph. There is our x equal to 0 and this is our x equal to 2. So then we plug it back. So if x equal to 0 imply that y is equal to minus 0 plus 1, which is 1, and x equal to 2 implies y is equal to 2, minus 2 plus 1, which is negative 1, and that is our other value, 2 minus 1. So C is 2 minus 1 and D is 0, 1. So in this case, if K is negative, remember that minus 1 over X, we can write that as minus 1 over X minus 1. Therefore, my K is equal to minus 1, which is less than 0. So that's why I say K is negative. But P is positive because in the formula we have K over X minus P. So my P is positive because I had X minus 1. So my P is equal to 1, which is positive. There, I've also written it there. So if it happens like this, if K is negative and P is positive, the K negative just tells us in which quadrants we're going to land. In the P positive, it shifts the hyperbola horizontally P units to the right. In this case, it was 1 unit to the right.